Repeat Physics 1, it's Mr. Ng, and I have a video on example 6.5. I wanted to start our discussion of energy with this one because it goes through a very basic equation that we just got to start using a lot of. And that is that kinetic energy can be calculated as 1/2 mv squared. Don't forget that work is also the change in kinetic energy, and that work is also force times distance. But really, we are working off this equation for this problem. It's just getting used to using 1/2 mv squared. So if we go through this example, how much net work is required to accelerate a 1,000 kilogram car? So we already have a mass there from 20 meters per second to 30 meters per second. So let's use this equation, change in kinetic energy. All right, so the work is equal to the change in kinetic energy. That means it's the final kinetic energy minus the initial kinetic energy, right? Meaning it's going to be 1/2 mv, the final v squared, minus 1/2 mv, the initial v squared, right? I don't think we're lost here. We already know our masses is going to be 1,000. We already know these are our two velocities. So the math is going to be fairly simple. I'm going to simplify a little bit. I'm going to take the 1/2 m out. So this becomes 1/2 m times v final squared minus v initial squared. So this becomes 1/2 times 1,000 times 30 squared minus 20 squared. So let's punch that through. Let me grab a calculator here. 30 squared minus 20 squared. We got 500 times 500. So I got 2.5 times 10 to the 5. 2.5 times 10 to the 5. The unit here is going to be Newton meters or joules. Seems pretty darn easy. So it takes a ton of joules to accelerate a car from 20 miles per hour or 20 meters per second to 30 meters per second, right? And the big deal with this problem is just using 1/2 mv squared. Thanks for watching.